All right, I think everybody's on board, so we're going to go ahead and start. So today we're going to talk about QuietSwing Heavy Duty doors. We've got quite a variety. We have oversized doors, special purpose doors, we've got heavy duty doors, and doors that they refer to in some markets as elephant doors. Thanks for joining us. My name is Steve Mitchell. I'm the founder of Noise Barriers, and I'm going to be your host for this presentation. I hope you'll find it informative. The purpose of the webinar is to introduce you to the many variations of these heavy-duty and special application doors offered by Noise Barriers. We have a lot of photographs, but we'll also have some technical data. So why should someone consider Noise Barriers for their heavy-duty and specialty doors? First of all, we offer multiple door designs and STC ratings, and we've developed a fast and a very safe installation method on these big, heavy doors. We've got in-house design capability, which we couple with PE services familiar with our product, which allow us to easily design one-off door solutions. And it also helps us to accurately and quickly bid projects to prepare the submittals and get shop releases done at a minimal cost. We've got the capability to quickly assist any consultant, architect, construction manager, or owner on any size door project anywhere in the country. And a lot of these are unusual doors, using the background that we've got in acoustics and door manufacturing to come up with one-off solutions. We build mock-ups of all these one-off door designs. We actually pre-hang them in the shop. We adjust all swing doors before shipping them. We also offer multiple door designs, multiple STC ratings, and as I said, that fast, safe installation design, which we're going to show you later. Typically on these doors, our scope is to handle the door design, including any PE calculations. We supply the door, which we manufacture, and the frame. We also supply the hardware and installation services. We really offer a total turnkey capability. We can design and supply an acoustic specialty door to meet the most unusual and rigorous applications, and you're going to see some of them in this presentation. We call these doors quiet swing, quiet slide, or quiet lift. Pretty self-explanatory. So what kind of heavy-duty doors do we have? We've got heavy-duty single-leaf doors. We've got heavy-duty double-leaf doors. We provide doors with unequal leaves. We've got triple-leaf doors. We can do bifolding doors, and we can do pivoting doors. We also do bullet-resistant doors. Typical uses for these are theaters, performing arts, sound stages. We do a lot of test cells of all kinds for engines, vehicles, any noise-generating products. We've been involved in both interior and exterior applications. We've done applications requiring oversized or unusual doors, and you'll see some photos of these. We do a lot of these doors in manufacturing process areas, genset enclosures, mechanical rooms, compressor rooms, any application where it's a crazy one-of-a-kind kind of a door. This happens to be me standing in front of some 16-foot by 16-foot heavy-duty doors. These are at Telemundo down in Miami, and actually I'm in the studio right now. This is the push side of the door. This is actually where they filmed the TV show The Voice. So it's a big sound stage. These heavy-duty doors, now we're talking swing doors, typically include cam lift heavy-duty hinges. There are 2 or more hinges per leaf, depending on the door size. These big doors, which are 16 feet tall, had 3. We use either a Cremone or a Haco bolt, factory installed. What my hand is on, what's called a Cremone bolt. And basically what that's got is a latch at the top and the bottom, and when you turn the handle, it retracts the latch. At Haco's similar design. On some of these doors, we provide a drop-down extra clamp seal at the door bottom, and it's built into the door. I'll show you a picture of that shortly. We are the only oversized door in the market that allows replacement of the bottom seal without removing the door from the hinges. Seals do wear out, and other designs require you to actually lift that door off of the hinges lay it down so you have access to remove the seal. You can imagine how it's not only difficult, a little bit dangerous, but it's going to take a lot of money to do it. We can provide these doors with closers on some applications. They're not always available, but in some applications they are. We do have special panic exit devices available. And in some applications, we'll provide an aluminum or steel threshold. This is just another picture of that same door I was standing in front of. On the left side, you see the pull handles. On the right, you see the doors completely open. These are 16 feet by 16 feet. This is another picture. There are actually 8 of these along this corridor, 8 sets of double leaf doors, and then there's some single leaf doors. This is an 8-foot by 16-foot door, and next to it is a little 3 by 7 STC 54 door. Typically, these heavy-duty swing doors and even some of our sliding doors are 5 inches thick and have an STC of 50. We can get a higher STC ratings, and we go thicker if necessary. The frame may vary depending upon the STC and door thickness. These can be split frame or angle stop frame with acoustic baffles. We can have these doors designed for pressure rating up to 100 pounds per square foot. We use either double magnetic seals or compression seals, just varies from door to door. The largest leaf size for our standard architectural doors is 48 inches wide by 12 feet high, or 60-inch wide leaf by 120-inch high. If a door leaf has to be any larger than that, we have to go to our heavy-duty door design. That's because of the type of hinges we need to use, the type of means of connecting it to the host building wall, the internals of the door, how it's built. So any doors larger than the 2 I just showed you, there have to be our heavy-duty door design. This is an example of what we're talking about. This is a 20-foot by 20-foot door. It's actually curved, and it's got a 3 by 7 personnel door in it. This is an STC 54 door. This is actually put into a building where they build the Abrams tanks. Every time they finish a tank, they open this door and they drive it out into their lot. The door had to be built on a curve to meet the curve of the building. This building was built right after World War II, and the curvature inside that building has to do with some ventilation things that they're doing. And they tore down the old door and had us supply this new door. So it had to be curved. So we have structural steel members inside this that were all curved, and we got it right the first time. They did a great job with this. We took it up there. That door installed in 2 days. When I talk about drop-down seals, what you see in the right-hand picture are some red handles. Those are just little Destaco clamps that when you lift it up, it raises that rod, which lifts the seal that's built into the bottom of the door. This was done in this application because the customer was doing some high airflow pressurizing this room, and they didn't want they want to make sure that they were getting no airflow out of the room. So this provided some additional seal at the bottom. And we've done that on other acoustic doors. The photo on the left is the same door with the Commode bolts just shown from the outside. This is a door that's at the Oriental Theater in Chicago. It's from the scene stage, or from the back of the stage, right out into an alley where they come in and unload trucks with scenery and things for the performances. On the other side of this, there's also a vertical lift door that we supplied. So when you walk through this door, about 30 feet straight ahead, you're actually on the stage. Typical drawing for a double leaf door. You can see we provide a lot of detail. I'm not going to go over the detail here because it's difficult to see, but we provide very detailed drawings. Basically show you how the door is built. This would be a typical section on this door. You can see at where the hinges are, there's steel embedment that we call out. Typically that's put in by a general contractor if the wall is already there. For example, at Detroit Arsenal, we provided this steel embedment. So that is what the hinges get attached to to swing the door. Typical head detail that we provide on all our approval drawings, showing how the carbon bolt or the ACO bolt secures the door at the head and at the sill. I want to talk about acoustic performance on these a little bit. It's very difficult, if not impossible, to test heavy duty and some of these special function doors you're going to see at a NAVLAP accredited lab, such as Architectural Testing, Riverbank, and US Gypsum, and this is true for many reasons. First of all, the unusual sizes and configurations just don't lend themselves to being tested. We would need to embed steel channel in the test opening to hang doors. We did that once, and the testing lab said they don't want us to do that anymore because it affects their wall. So we really can't test some of these in an independent lab. And of course, cost. Some of these are one-off doors, and we just can't test each door every time. But we do test them in our own facility. We use the ASTM E2964-19 method, which is the standard test method for measurement of the normalized insertion loss of doors. Using this method, what we've seen is test results are within 3 points of what we can achieve in a lab STC test. On smaller doors, when we've actually tested using this method and then we can go verify at the lab, we've actually been within ±1 STC rating. If there's an acoustic consultant involved in the project, we invite them in to witness the testing. So we're happy to have them take a look at it. We've actually had the State Department has come in and did some of their own testing without us, watching the test. So we're happy to accommodate that. We can't use an NIC test because these results just would not be accurate and they won't correlate with lab tests due to the constraints of our in-house test capability. What it really comes down to is we're testing from an acoustic sound room where we can generate about 130 dB of noise, and then we're reading that out in a 48,000 square foot manufacturing area with all the equipment shut off. And that just doesn't give an accurate NIC because it's not a real life situation. But that other ASTM E2964 is very accurate. But most importantly, on all of these special doors, we'll guarantee the field performance of the doors. This is the typical wording that you see in specifications. At the discretion of the owner, architect, or project acoustic consultant, performance testing may be performed. And we typically guarantee that we're going to be within 5 or 6 points. So it's the standard that's in the even architectural doors. So we have no problem guaranteeing field performance on these doors. I did receive an email about a month ago before my first presentation from Richard Talaski, who's an acoustic consultant in Chicago. And he asked me to address the following. He wanted to know, are these QuietSwing doors, meaning these big heavy duties, are they really quiet in operation? No panic hardware latching noise, no door closer noise, no gas sweep compression noise. He also is just reminding me that they work on design of many theaters and concert halls, and the quiet operation of the doors is very important to them, as well as the TL performance. And I've done a lot of jobs with Rick over the years, and he does go out and test. So our response is this. The hinges we use do not make any sound. On large doors like these, a closer is not available due to the size and weight. There are some operators we can use, but they are not noisy. The bottom seal is similar to that on our smaller doors. It's a Teflon-coated neoprene compression seal or a manual crankdown seal. That operation is quiet. There is no gasket sweep. There's nothing that's dragging across the floor. Once as soon as the door starts to open, the cam lift hinges lifted up. On their sliding doors or these big swing doors, they're manually operated, and if they're going to be open during a performance, the person disengaging or engaging the hardware needs to be mindful of the performance and not just slam the door shut. So it's not going to be the door's fault it's going to be an operator function. And if there's really concern, as we pointed out to Rick, we can always put the hardware on the noise side of the door and keep it away from the performance side. On our sliding doors, we're not going to talk about sliding doors very much today. I'll show you a couple of examples, I think, of some moving doors, but we have developed a very quiet motor-operated sliding door system, which would be the focus of another webinar. We use a different type of transfer mechanism and drive mechanism with very low horsepower motors, and that is a very quiet operation. Basically a guide rail and block system with track and trolleys, and it's just a very quiet system. And it's the systems that we use these on some of these special doors that you're going to see. We've cycle tested these in our shop well over 200,000 times with a counter on it, with no loss of performance, no deterioration of the drive system or the track guide rail and block system. Great system. All right, so what have we done to make these easier to lift? We're the only manufacturer that provides two features that simplify the installation and maintenance. One, on oversized doors, we provide removable lifting lugs either on the face of the door or the top of the door. These allow these doors to be lifted with overhead equipment in lieu of a strap. In the past, I used to install with crews that I had before Noise Bears a lot of doors for another manufacturer, and we'd have to wrap the door with a strap to lift it up. Well, that's dangerous. You know, you have to have the strap correctly positioned. You have to, you still have to get that strap off when you get it into the opening. Very difficult to do. With this system, we can lift this door up, set it right on the pins of the hinge, take the hoist mechanism off, take the lifting lug off, and close the door. So it's a much easier, it's a fast installation, and it's very safe. Also in these oversized doors, we include a mortise bottom compression seal. This seal can be easily removed and replaced without the need for removing the door from the hinges. I mentioned that earlier. That saves a lot of hours of work, which would take a crew of probably 2 workers plus a third worker to be driving the hoist. And this is an example of it. This happens to be some doors we did at the Ellsworth Air Force Base, where they, on the other side of these doors are F-35 fighter flight simulators that actually the Navy uses on an Air Force base to practice carrier landings. And these doors have these lifting lugs. You can see that they've just lifted this door into place with this yellow strap. After the door is secured, they can unbolt these lifting lugs, and we've got some plugs that go in there and seal it off. And so you see that they can lift that without having to strap it. Across the bottom, you'll see some fasteners, and this is where we have access to the bottom seal, and this is what it looks like. So the bottom seal is adjustable through the lower fastener. That, when it's loosened, can slide up or down, which allows the compression seal to move up or down to close off any little gaps between the floor and the door. In the event that that needs to be changed, instead of taking the whole door down, there's a series of these bolts across the top edge of it. You just remove those, pull the cover plate off. You now have access to the bottom seal, and you can replace that seal. So you can replace that seal in about an hour instead of having to take 3 men to lift it off, lay it down somewhere, bring in a small hoist. So it's a much safer installation, and it's much quicker. So some of the goofy doors we do, we've done offset leads. These are at the CBS studio in Chicago. This is another set of offset leads where we've got a 5-foot leaf and a 3-foot leaf. Variety of reasons somebody might want unequal leads. We're happy to accommodate that. These are some doors where somebody, our customer on this, BORG Warner, they needed the doors to be lined with stainless steel. We did that. That's our standard architectural door, but it was a special function. So it's easy for us to accommodate that. This is a tri-leaf door that is at the DuPage School of Music in Chicago. It's 18 feet tall. What you have on the left side is a personnel door, an 8-foot high personnel door with a 10-foot leaf above it. And then on the right side is an 8-foot by 18-foot high door. So normal operation day in, day out. The people are going to walk in and out through the personnel door, and then when they need to move some large equipment through it, they can open both sides. I want to show you this. This is a bifold tri-leaf door that we've done. This is taken in the shop. So this happens to be an 8-foot by 12-foot door, but it shows how easily that the bifold door, in this case, operates. We're actually in the process of manufacturing one right now that's 30 feet wide. It's 6 leaves, 11 feet tall, STC 56 for a recording studio. So we can get quite large with these. We've also can do 1 PSI blast rated doors. This is a piggyback door we did for General Motors. So the STC acoustic rating, so it has some blast rating with it. And in this case, you can see the motor in the upper left-hand corner. So this is a motorized power-activated door. These are just some large doors at a Caterpillar, it's the old electromotive plant where they make railroad engines. And these large doors are enclosures we built out in their lot a couple of years ago. They actually test every railroad engine that they make. They go in here on the tracks, run it, but had some unusual requirements here in terms of size and acoustic rating. This is another example of, like that tri-leaf door I showed you where you have a personnel door. And some of these oversized doors, even on our horizontal sliding doors, we can actually provide a personnel door leaf within a leaf. So here you got a 14 by 18. This is also up at that facility in Detroit Arsenal. Did not have to be curved, but we did a number of these kind of doors. And on the right, we just have some single leaf doors that are pressure rated. So acoustic as well as pressure rated. This is a project we did for a Homeland Security SWAT training facility on a college campus. The facility actually is a gun range. They have SWAT officers practicing tactics and as well as live ammunition around in here. And we did quite a few doors that met NIJ 4 bullet resistance. And it occurred to them after the fact that they had officers coming in here in SWAT gear, unloading weapons out on the curbside and carrying them into the building, and students were getting a little freaked out, as you can imagine. So this was an add-on after the fact. They actually added this vertical lift door to provide a means for an SUV that has weapons in it to be driven into the facility that can be unloaded and pulled out. So it's just an unusual application. And it was so unusual that they didn't have enough headroom to put in a vertical lift door, nor did just do one slab going all the way up, flat across the top. But in this case, we had to make the door kind of an unusual size to accommodate the head conditions. So again, special purpose door using our standard componentry. Special doors aren't always large. We also can do small access plugs or hatches. We see a lot of these in studios to provide access to wiring and control panels that might be built into walls. These particular units were used at a performing arts center and are actually roof hatches that were up on the interstitial ceiling and were used to change the light bulbs above the auditorium. So if somebody walked across the ceiling, opened this door, could reach down, change a light bulb. These are actually UL rated for 90 minutes. We also do pivot doors with a center point. This is a project between the foyer or waiting area and church facilities. So you're looking into the sanctuary. When the service is over, they're able to pivot these doors and allow the people to egress to the auditorium. We did some pivot tours a couple years ago, actually about a year and a half ago, up at the Museum of Modern Art in New York. This is an 18-foot high, about a 5-foot wide door. I'm sorry, 6-foot wide. It's 6 by 16 feet. It's got a 3 by 7 personnel door. These were double vestibule doors leading into a couple of studios that they have at the moment. There were 4 of these altogether. The frame and the doors have rounded corners. This is nothing square about the big main door on this. It has pneumatic seals all around the perimeter, which is why we had the curve at the 4 corners. STC 50. And the architect, consultant, contractor, owner all visited noise barriers to see the mock-up operate and observe an acoustical test that we did on this before they gave us the approval to go ahead with final manufacturing and get those doors delivered. These actually operate off of a pin on the right side of the door. There's a pin at the top and a pin at the bottom. So there's no hinges on the main door. It operates like a pivot door. We also do L-shaped doors. This is typical for people that have some type of an acoustic enclosure where they need to get equipment in using an overhead crane. So the door is L-shaped. It goes up the face of the enclosure and then back as deep as we need to go to provide clear access to a crane coming in from the, to drop parts down from the top. Typical drawing here, the hashed area is the roof. Those slide to the left and to the right. It's the front. So that's a one-piece door on each side. So it's one piece L on the right, one piece L on the left. This is just the typical detail that we would provide to the owner or architect to review for construction. We've also done bifold doors like this. This is power activated. This is at a theater in Chicago, or actually in Joliet, Illinois. It's in a little museum. This is a room where people come in. You can see the benches. You come in, you watch a little video about what this museum is all about. When the video is over, the screen retracts up into the ceiling. Here you see a silver line across the ceiling by the motors, and then the doors open up. It's kind of a ta-da! Here we are in the main theater. So how do those operate? This is similar type of doors that we did at Caterpillar, the Caterpillar facility. It's about 14-foot high by 12-foot wide. So it's power operated. The reason for this is they just didn't have space for a big full swing door. They didn't have enough because there's all types of equipment about where the camera person is. So they had to have a bifold application on this. We can do communicating doors where we match up different STC ratings to get whatever acoustic rating a person would need, in this case an STC 60. We've also done some large doors. This is kind of like that L shape, but the L didn't have to be so big. So we have some 20-foot high doors here with 4 pneumatically actuated doors at top that open in a sequence, left, right, and then they close in the opposite sequence to create an acoustic seal. So every one of these is just kind of a one-off special door, and we're glad to take on those challenges. 12-foot by 12-foot double-leaf door on an enclosure, so that's not an unusual application. So the common features of these doors is we use 14-gauge solid skin, 11-gauge solid skin. We can go heavier. As I said earlier, they can be 5 inches thick. The doors down there at Telemundo were actually 9 inches thick. Those are the first doors you saw. When we build these, the structural frame is of the door leaf is damp, and the skins are damped as well to create to isolate any vibration that might go through them. Standard materials we use are A60 galvannealed steel. We can use G90. We can use stainless if necessary. We can use cold rolled steel if somebody wants us to. So what we provide are turnkey capabilities. Again, we handle the design. We'll do the PE stamp if necessary. We provide the doors and all installation services. I think you can see we've got unlimited door designs to meet architectural and acoustic performance requirements. We've developed a fast and very safe method of installing heavy-duty doors. And this is very important because these are typically going into difficult installation situations, and it's good to have something that is easy to install as these doors are. We do provide these with powder paint finish, size permitted. We'll use any standard REL color, and we custom match other colors if necessary. And we have the longest warranty in the door industry with 5 years. So that's just a final shot. This is our literature. That's a single leaf door down at, another one of them down there at Telemundo. If you have any additional information that you need, please reach out to marketing@noisebarriers.com. Questions about these heavy duty or special doors? If you want to receive sample specifications, AutoCAD drawings, or budget pricings, if you need any information on any Noise Barriers products, please reach out to marketing@noisebarriers.com. I know your time is valuable. I want to thank you for listening to this presentation. Please reach out if we can do anything to be of service to you. Thank you, and have a good day.